Okay, I wasn't gonna, but I'm gonna say just a little more about this. Okay, here's your delta V. We can factor out a VI squared under the square root here, and we end up with VI times the square root of 2KE over mv squared plus 1 minus VI squared plus 1 minus 1. Okay? And that's very straightforward. Okay? Well, this thing is always positive. Okay? This kinetic energy can't be negative. mv squared can't be negative. V squared has to be positive. M is positive. Okay? Is always positive, and the denominator is always positive for the same reason. And actually, well, I've got some bad notation here. I started writing down KE rather than delta KE. And there should be a delta KE here. Okay, because again, we're talking about how much the velocity changes to increase the kinetic energy by the same amount. So, with that correction, your delta V is VI times 2 delta KE over this and so forth. Okay, well, the point is that the bigger VI is, the smaller this fraction is. Okay? And the smaller this fraction is, the closer the expression under the radical here now is to 1. Okay? And of course, the smaller VI is, the larger this thing is. Okay? And the more this square root exceeds 1. And since you're subtracting 1 from the square root, this shows you that for large VI, you need almost no change in velocity, very tiny change in velocity. So if you're moving at 100 meters per second, you don't need much change in velocity to change your velocity by 40 joules. Okay. On the other hand, if VI is very small, then this term gets much larger. Okay. Now I'm getting something that's sort of counterintuitive. As VI approaches 0, what's the limit of this thing? Obviously, this term's going to go to infinity, so you're going to have a large term here. But of course, that's balanced by the fact that VI goes to 0 over here. So you would have to go back probably to this form to show what happens as VI approaches 0. And you get a pretty obvious result. Anyhow, it's worth thinking about. We're seeing how these algebraic rearrangements illuminate our intuition. Not that on an introductory level, you have a whole lot of intuition about kinetic energy anyway, but kind of an interesting thing to think about. Okay.